Welcome to Pachehra Talks. My name is Arun and I'm Solutions Architect, MCT, working with Novintech, which is one of the best organization to work with. And today we are going to understand magic of Azure Front Door. The magic that Azure Front Door does that we established in the previous videos. In today's videos, we are trying to understand how exactly Azure Front Door does what it does. So there are two friends of Azure Front Door, Anycast and Split TCP, which makes Azure Front Door what it is. All those wonderful features that is provided by Azure Front Door is because of Anycast and Split TCP. So today we are going to understand what is Anycast and what is Split TCP, how it helps Azure Front Door, what are the benefits of utilizing these things by Azure Front Door. So let's get started. I have prepared this small architecture. Let me take you through the architecture. Let's suppose this is Azure subscription, where we have two regions, region 1 and region 2, where the applications are running. And this is a Microsoft backbone network, which is a global private network of Microsoft, which has a good bandwidth, good speed, and secure, of course, reliable and secure. And these are the pop locations of every region. They're like multiple pop locations. And we have created one front door so that we can cater the request coming from all over the world. Why? Because it is a global service, right? And it can divert to the right application or the right region as per the routing rules. Just to refresh our mind and take you through this architecture that we have created, and this is our client who is trying to access that we will try to understand from the aspect of Anycast and split TCP. So before we start, what is Anycast? Anycast we need to understand first, then we'll take this understanding or concept of Anycast through our Azure Front Door traffic routing or traffic flow. It will help us understand all those wonderful features that Azure Front Door offers, how it actually offers. All right. So Anycast is a network addressing and routing methodology. What it is network addressing and routing methodology in which incoming requests can be directed to a variety of different locations or nodes. So in our case, incoming request to front door diverted to multiple edge locations. And when we created all those configuration that we have selected for the front door, what happens? The Microsoft publish those configuration to all the edge locations that Microsoft has, all the configurations through Anycast. Right, so the public IP that we have selected, the endpoint that we have selected for the front door is published to all the edge locations globally. It is a global service. So this approach is something that will help Azure Front Door to optimize and accelerate the delivery of web content and services by directing user requests to the nearest or most available point of presence. So what happened? This is happening due to TCP. Oh, this is happening due to Anycast. Forget TCP. This came into my mind because of Anycast. All these pop locations have that configuration with them. All that public IP established or published to all the edge locations. So when the client sends a request, Frendo receives it and it will divert it to the nearest location. If it is directing it to the nearest location, what is happening? Well, it is optimizing it and accelerating the delivery of web content, right? So this is happening because of Anycast. So how Anycast actually works? Well, Azure Front Door utilizes Anycast IP technology combined with Microsoft Global Network Infrastructure to enhance the speed and reliability of web applications. Why? Because of the global network presence. So what it is doing, global this front door, it is utilizing the Anycast IP technology so that all these edge location has the same IP or the configuration that we have published here, which is actually the public IP. And once request comes to this location because of that public IP, which is the nearest. Let's suppose this is the nearest. Request will come here, then it will get into the Microsoft private network. So it has two benefits. Through edge location, it will get inside the global private network of Microsoft, and benefits of edge locations or POP like caching. Okay, so that's how. All right, so these POPs are strategically located in numerous geographical regions to provide widespread coverage all over the world. Okay, so how it actually happens: Azure Front Door uses a single global Anycast IP address for your application or service. This means that regardless of where a user request originates, it is always routed to the same IP address, right? Then, when a user makes a request to a service that is front end by Azure Front Door, the request is initially routed to the nearest Azure network edge point based on the network topology and the shortest available path. Shortest available path. Okay, we need not to forget that. So this routing is facilitated by the global routing infrastructure, which uses the Anycast protocol to ensure that the user's request reaches the closest or the most optimal POP, right? And for example, if a user from London access website hosted in the US with Azure Front Door, the request will be intercepted by the nearest global POP. Nearest global POP. Uh, Nearest to who? Nearest to London. This could be in London itself or another close European location. So that's how the request is getting in. But there is also load balancing and failover. How that is happening? Well, inside the selected POP, that front door configuration selects as per the uh, available shortest path and nearest location. Well, it assesses the health and performance metrics of various backend resources, such as web servers that are available to serve the request, because we have already that configuration in the Azure front door, which is already published to all the Azure location. They have that information. If the nearest backend is experiencing issue or is deemed suboptimal, the request can be rerouted to the next best backend using Microsoft's internal backbone rather than public internet. This not only increases reliability but also reduces latency. Now, since we are talking POP and edge location, so we cannot forget the caching and acceleration. So Azure Front Door also includes caching capabilities at the edge locations or POP. Static content like images, files, JavaScript can be cached closer to the user, reducing the load on the origin server and further decreasing the response time. This means that subsequent requests for the same content do not need to travel all the way to the origin server, but can be served directly from the edge location from the cache, because once the first request arrives here, all that content would be cached here. Okay. Now we can just summarize this with the help of an example. Let's suppose you run an e-commerce platform hosted in the East US region. Let's suppose this is the East US region, but you have a significant customer base in Europe and Asia. Let's suppose this is our customer. Without Azure Front Door and its Anycast technology, user from Europe and Asia will go via internet. Let's suppose this is internet. So request will go via internet. From internet, then it will come here, right? Which means higher latency, as their requests need to travel long distance to the US based servers. All right. And with Azure Front Door, let's suppose now we have added Front Door because we knew about it now. So user in Tokyo would send a request that is routed to the nearest Azure POP. Request will go to Front Door and it will send to the nearest POP. Nearest POP where in Asia, for example, Tokyo or Singapore, the request processed at the POP would access cached content directly if available. If not cached or for dynamic content, the request might still be served from Asia, where Azure Front Door chooses the optimal backend based on the health, latency, load, possibly using the application servers in the East US. So, in summary, Azure Front uses use of Anycast IP technology helps distribute user requests intelligently across a global network, minimizing minimizing latency, improving load times, and enhancing the overall reliability and performance of the web service. So that's all about Anycast. Now let's quickly check the split TCP. As the name says, that's what it is. It's going to split the TCP. Why? We understand that. So split TCP is another key technology used by Azure Front Door to optimize and accelerate web traffic. Technique enhances the performance of network communication between clients, which means user and the servers. Uh, for us, it is for this particular situation, client is talking to front door, and then it is front door through front door to the POP, and then POP to the backend. So ultimately, this technique enhances the performance of network communication between client and the servers by breaking up the TCP. It's if it is not there, then the request will go to through the internet to here directly. Then it's a huge TCP connection. But in our situation, here the TCP is getting broke or the at the edge location. So there is one connection till here and another connection till here to the backend. So that's what the TCP split is. From here, it's getting split. This method is especially effective in reducing latency and improving the speed of the content delivery over long distances. Let's see how. Well, in a typical TCP connection setup without split TCP, the connection is established directly between the client and the server at the backend, as we already talked about. This single long TCP connection can suffer from higher latency, especially over long distance due to TCP nature of requiring acknowledgement packets before sending more data. Right? TCP acknowledgement. Acknowledgement. All right. And Azure Front Door implements split TCP by dividing this connection into two separate TCP connection, as I said, between client and edge, and then edge and servers. So it is breaking that into two. So how it helps then? When a client makes a request, it connects to the nearest Azure Front Door POP. This segment of the connection typically experience low latency because POP is geographically closer to the user. These are closer to the user. That's what the Anycast is doing, sending to the closest and the most available shortest path. So Azure Front Door maintains a pool of pre-established TCP connection from its edge nodes to the backend server. These connections can be optimized for long distance transmission using Microsoft Vast Backbone Network, which is designed for the high performance. Right? So see how everything is coming together and helping each other and giving us less latency and high performance. So by splitting the TCP connection, Azure Front Door can manage data more efficiently. The Edge node can quickly acknowledge packets to the client, reducing the time the clients wait for the acknowledgements. So because it is shortest, no need to wait, and thus speeding up the loading process. Similarly, the Edge node handles acknowledgement from the backend, allowing it to tune the TCP parameters like window size and round trip optimally for the backend segment, which might involve longer distance and thus different network characteristics. So we can consolidate this and summarize this with the help of simple example. Imagine a user in London accessing a service whose backend is hosted in the Azure US West region. Without split TCP, the user request would travel across Atlantic, waiting for acknowledgements to traverse this long distance, which adds to latency. With Azure Front Door using split TCP, the user request must travel to the nearest front door POP in London. The connection from the user to the POP is quick due to the short distance, At the London POP, Azure Front Door terminates the client's TCP connection, quickly processes the request, and sends back an acknowledgement. This rapid exchange keeps the client's network stack ready to send more data without waiting for acknowledgement from the distant backend server. Simultaneously, London POP uses its optimized long distance TCP connection to communicate with the backend in the US West region. This connection is managed independently of the client's connection, allowing Azure to optimize it for the uh, journey. Now, data from the backend is returned to the London POP, which then quickly forwards it to the client. Data can be cached for the other request. So, what are the benefits we are getting? Reduced latency, increased throughput, more efficient use of the network connection enhances the data throughput. So, increased throughput and the reliability, of course, because of the client. So many POP locations, POP backend connections isolate network issues to either segment without affecting the other. So, by employing split TCP, Azure Front Door enhances user experience by providing faster, more reliable access to web application, especially when user and servers are geographically dispersed. So, these are the two magic thing with the help of which Azure Front Door is what it is. Anycast, all those have the same configuration and IP address and can be utilized easily through front door, and the split TCP, breaking the TCP into two, client to edge, edge to backend. So that's all about today's video. I hope it was informative and you liked it. Thank you for watching and you guys have a wonderful day.